And welcome to the Daily Space Weather Show. Today we're bringing you some footage that we don't normally show the wavelengths of. So, also you might see some SDO calibration maneuvers unfortunately happening there, messing up the imagery big time. We do have more sunspots though to report on. We'll also do a cosmic ray report tonight. And we might even do some criticism of utter lunatics on the internet. So here's just 1700 angstroms by itself. And we're going to get back to those wavelengths. We're also going to show you 1600 angstroms for an extended period. Here we've added 131 angstroms to it. And let's take a look at sunspots here for a brief moment. We're now back up over 150 sunspots on the visible side of the closest star. There is colorized magnetogram from SDO for today, January 17th. And by the way, thanks for tuning into the Smash News Network, least busted name in news. Congratulations on realizing the channel exists. And make sure you let us know in the comments what you think we ought to do for our 5,000 subscriber special, which is coming. Let's briefly look at volcanoes. Luotobi is erupting. Pretty dangerous volcano there, Luotobi, folks. Also a new map for Grindavik. You can check that out yourself if you like at volcanodiscovery.com. So here's the list of erupting volcanoes. And there's some ground deformation continuing there at Reykjanes as newly formed lava settles, usually causing it to collapse, because of gas bubbles and so forth. So there are the rest of your erupting issues. Whatever you do, folks, if you're going on a volcanic vacation, leave that vault pole at home. Don't pole vault the caldera. Next, we'll cover earthquakes. We'll shout out quakes of a 5 and greater magnitude. There are the past 90 days of large quakes. Here are the past 24 hours. And it's been quite calm here, so not a lot of quakes, period, and not a lot of quakes over a 5 magnitude, that's for sure. Mostly around the Pacific Rim, as you may come to expect if you know anything about earthquakes. There was a mild swarm in the Caribbean, though, or the Leeward Islands. I'm not sure which, and I don't care. But the Philippines had a 5.6. That was at 12:32 this afternoon, Universal Time. And then Mariana Islands region had a 5.0, only about 28 minutes later. And then only one other 5 or greater magnitude quake, that 5.1 at the southeast central Pacific Ocean, in the middle of nowhere, out toward the Galapagos, a little bit past the Galapagos, I think. Anyway, that's the quake situation, and let's get back to space. Space, a frontier. These are the voyages of SDO for the past 24 hours. That's 1,600 angstroms plus 131 angstroms, 60-minute running difference imagery. And before we get to things like coronal holes, let's talk about some stats. The 10.7 centimeter radial flux is now down to, I think it's 174. 174 is the radial flux, if I remember correctly. And my mind is like a steel trap, so you can bet on that. 174 is the new radial flux number. There's Solon.info's 1-year graph. The black line is the radial flux. The red line is the sunspot number. They are directly proportional, and the two best representatives of the activity of a solar cycle as we ramp up and up and up to solar maximum. Meanwhile, NOAA's not forecasting any geomagnetic storms or geomagnetic unrest. Interestingly enough, we are seeing a coronal hole high-speed stream. The leading density wave that we always see with coronal holes is just arriving right now. So a couple of days ago, I would have forecasted that. I would have said, hey, we got a likely coronal hole high-speed stream. It's not going to be strong and it's not going to be long, but looks like there is some activity showing up. We'll get to that momentarily. First Earth's magnetic moment from space for the past 4 hours. So here's our geospace magnetosphere movie. Let me bring that back for you to play the whole run. And you'll see an increase in the magnetohydrodynamic pressure here sometime during this video, because like I said, we've recently, just in the past hour or two, had a density wave show up. So this is the predecessor to the high-speed portion of a coronal hole high-speed stream, and there's that density wave that I just mentioned. Next, the past 4 hours of Earth magnetic moment from the ground level. You'll see similar ground magnetic perturbations kicking up, so this increases the likelihood of the ability to see the aurora, folks. And you can actually use this map to predict the aurora. If it's visible overhead, you might indeed have telluric currents underfoot as well at the exact same time, and there you can see the likely places for the aurora kicking up. KP index currently at 1. KP1 is the planetary K index, an average of global geomagnetism. And let's skip the ACE entirely, as it's not very interesting. The Discover showing much more interesting data there. Solar wind density here making it up to nearly 20 protons per cubic centimeter. So that's very typical of a coronal hole high-speed stream density wave, which precedes coronal hole high-speed streams most of the time. And we still haven't seen the big uptick in the coronal hole high-speed portion. So it's basically we've got the density wave, but we haven't seen the density dip down yet. So what you can expect to see in the coming, the coming 6 hours would be a dip in the solar wind density marked by an increase in the solar wind velocity. They'll happen at roughly the same time. So that'll be what to expect. That's called forecasting and understanding how the data ties together with the other data. So that's how we forecast, folks. And if you're watching channels who cover space weather and are unable to forecast tomorrow's sunrise, tell them we said hi and that they're cute. Anyway, GOES magnetometers there for the past 3 days are looking pretty smooth, and we can expect some sawtooth readings by tomorrow's video because, again, like I said, there is some high-speed plasma on the way. Will it cause any geomagnetic storms? I don't think so. Maybe a KP3 or maybe even a KP4, but probably not much more than that. Again, not only will it not be long-lasting, it won't be real strong because it's a fairly modest coronal hole. We covered it a couple of days ago. Anyway, next our top view ecliptic plane field plot. And like I said yesterday, Earth would still be in a North Pole current sheet, and indeed it is. So there's the North Pole magnetic sector. The north magnetic sector of the heliosphere there. Earth remains in that sector boundary, looking like it's still a couple of days out at this point as it has receded. So South Pole sector is still probably like 2 days out. However, keep in mind, sunspots can suddenly change that forecast with basically no warning. Next, our line of sight field plot. There's a lot of information about the past 4 days in one very convenient and fantastically detailed series of images. And here's our coronal hole line of sight plot. So, same thing, but this time showing coronal holes, which are super important to the solar cycle, in that coronal holes show us the solar polar field reversal process, which occurs in the corona, the layer above the chromosphere, which is above the photosphere, which is where sunspots occur. So let's take a look at coronal holes. How about from the SDO? Shall we? There we go. There, the past 24 hours. And the current coronal hole density wave is from this coronal hole right here. So showing up pretty much right on time, exactly what you would expect. And like NOAA, we're not expecting any major fireworks from it, but it will increase the aurora likelihood. If you have auroral imagery to share with us on the channel, the best place to do it is over on Twitter. There's a huge network of awesome people taking awesome imageries over there on Twitter. So yeah, that's where to share. x.com/smashomash. That's a /, by the way, if you're keeping track. And let's get to sunspots before we cover cosmic rays. Yeah, cosmic ray update coming today. But first, sunspot number, which, by the way, is inversely proportional to cosmic ray flux. That's right. When you see a strong solar cycle, you see very weak cosmic ray flux. And when you see very weak solar cycles, you see very strong cosmic ray flux. I'll get back to that in just a moment. But the sunspot number has just recently recrossed 150. And by the way, if you're viewing any channels on YouTube who think that 150 sunspots on the Earth-facing portion of the solar disk is an inactive sun, those people are berserk. All right? I mean, definitely watch it for the comedic value. Definitely leave a comment and say Smasho said hi. Oh, hi, yeah. 150 sunspots is not a dormant sun, folks. So, yeah. So, anyway, like I said, let's talk about that. Now that the sunspot number has just risen back up over 150, let's talk about cosmic ray flux. So, just to reiterate what I just said, all of these cosmic ray peaks, these are solar minima, right? So right here, this is the deepest solar minima of the modern era. As you can see, it has the highest cosmic ray flux. It also had the lowest levels of solar activity. As you can see with this cycle, that's the transition between solar cycle 24 and solar cycle 25, not as high levels of cosmic ray flux, right? Also worth noting is this very important factor. So don't hesitate to notice this. We're seeing the lowest levels of cosmic ray flux since 2004. So there are some facts for you, as a lot of people who have been declaring that, oh no, the sun's shutting down and it's very spooky and you should get yourself a bunker and all kinds of other equipment that you might never need. Because the sun's spookily shutting down, folks. Lowest levels of cosmic ray flux since 2004. Let's look at the rest of the monitors now, since that's OLU, and I don't cherry pick data. I look at all the data because I'm interested in reality, not joining a cult. So anyway, DOMB Antarctica is showing a little uptick over the past 30 days. That won't last long, as cosmic ray flux will drop to even lower levels than we currently are, sometime around between now and 5 months after solar maximum. DOMC Antarctica also showing a marginal uptick for the past 30 days. OLU also showing a marginal uptick for the past 30 days. Oh noes, folks, does that mean it's time to get in the bunker? Well, not at all. It's not scary in the slightest, as solar plasma mitigates the influx of cosmic rays. Next is, let's see, what is that? Mexico City's cosmic ray monitor, also a minor uptick in cosmic ray flux over the past 30 days. Athens, Greece, a very modest uptick in cosmic ray flux for the past 30 days. Barentsburg and Apatity. Barentsburg an uptick for the past 30 days, and also Apatity. However, once again, just let me reiterate, we've got the lowest levels of cosmic ray flux that we've seen since 2004. You let that sink in? Okay, cool. Anyway, back to sunspots. There's what 150 sunspots look like. And likelihood of flares is, well, there is some decent likelihood now, right? In two locations, down here in the southwestern limb and up here in the northeastern limb, where more new sunspots have risen. So guess what? Sunspot number, I suspect it's going to be nearly flat, as we've got a lot of setting groups down here in the southwest. But we also have some rising groups in the north, in the eastern limb. So, yeah, there are some facts for you. And here are sunspots. There is SDO 1700 angstroms. And let's get to some more facts about space weather, shall we? Next, we'll go to energetic particles and flares. So, at the moment, no spikes in the proton flux. Energetic particles are baseline. X-ray flux is still at about a C1.6, it looks like, for the background flux. 1.3, that's good enough. C1.3 background flux. Yeah, with over 150 sunspots on the Earth-facing portion of the disk. And before we get to our star chart, let's take a look at some more imagery from SDO. How about that? There is 131 plus 1600 angstroms. That's ionized carbon in the 1600 angstroms and ionized iron in the 131 angstroms. Here we've replaced the 1600 with 94 angstroms. Now we've just got two different species of ionized iron. What I mean by that is a different number of electrons and a different temperature. Those wavelengths, by the way, are part of the extreme ultraviolet spectrum. High intensity ultraviolet light is what those are representing. Was there a thing? Did a thing occur? I apologize if a thing occurred. Keep in mind, folks, that we don't edit the videos, so these are just like live streams, but they're shot in one take. That gets them onto your screens as quickly as possible, as they are very timely. Especially considering we have solar flare watches in two locations once again, both the northeastern and southwestern limbs. Anyway, before we get to CMEs, let's take a look at a star chart. So here's where things are located overhead right now, Lehigh Valley, PA. If you see a bright object near the moon, that would be Jupiter. Sometimes the fourth and sometimes the fifth brightest object, depending on the location of Mars. Next, a solar system forecast, courtesy of theplanetstoday.com. That's where things are today. That's where things will be in 1 week on the 24th. How time flies when you are the ownage. Anyway, check it out. We've got a 3D image here, which will make some people mad because they'll say, that's not real, the lunar landings are fake, or something. So that is a 3D image. So break out your 3D glasses if you have the red-blue kind, because that'll just be awesome. And that is following Apollo 17's lunar landing, taking a little shot of the landing site there on their way back to Earth. apod.nasa.gov is where to check it out. And let's move on to CMEs. CMEs, they're kind of important, as they can lead to major geomagnetic storms. They could even damage power grids. Who knows? But it's not looking like any of that stuff's going on now. But let's take a look a little closer here, since those are 81 frames from George Mason University. Here are some more frames from Soho Lasco C2 and C3. And it still looks pretty chill here. Plasma Miser is still holding out on plasma. Anyway, here are 24-hour videos, complete with the synchronized SDO, Lasco C3 and C2. And oh, what do we got? Do we have one with earthly directed components? Could be. Let's look a little bit closer here. So there's certainly some plasma motion happening right in this area. Certainly part of that filament ejected, and part of it crashed back down, and part of it stayed intact. I'm not so sure if that sent any ejecta Earth's way. It's a very tiny amount. I don't see anything too exciting in our forecast. Here we've added 193 angstroms as well. Yeah, if there are any CMEs there that have earthly directed components, they will not be major CME impacts. That's my story. I'm sticking to it. Here's the full disk view with those same wavelengths. That's 304 plus 193 angstroms. Great at showing filaments as I transition to filaments. So, filaments. First thing we'll show is the Cerro Tololo ground-based solar observatory depicting hydrogen alpha. It's 6,562.8 angstroms wavelength. And look at the filaments, massive filaments, and a lot of them. The guy's wife Maria filament is still growing since yesterday. And several more that could get names, at least 1, 2, 3, 4, 5, like 5 or 6 more filaments, maybe even up to 10 filaments could get names here. We even have some showing up in the western limb. Some of those will show up better. But, and check it out, also some large prominences rising there, an indication that there are more sunspots behind the eastern limb. So, yeah, that's what's going on. And let's bring up the latest here from the colored images, and that's a lot of filaments, folks. So there could be a major Earth-directed CME in our future based on all of those filaments. And, keep in mind, folks, you don't have to see filaments to see CMEs either. Sometimes we see massive CMEs pop off when there is absolutely no visible filament activity whatsoever. There'll be a smooth spot, and then a flare happens, and it's as if a large portion of the corona just peels off and is rapidly replaced with more plasma. Anyway, before we get to bonus features, these are the past couple of hours from the GOES 16 SUVI. And my favorite place for a large flare is 100% this southwestern limb, because there is certainly some plasma instability happening. You can actually see that right now. And remember, folks, many of us do not believe that solar flares cause CMEs. Many of us believe instead that the plasma motions cause the solar flares. There's a more plausible physics mechanism, or you could say physical mechanism, associated with the filaments causing the flares, not the flares causing the CMEs, if that makes sense. I don't know. Anyway, here come bonus features. Satellite charging hazards are first, and we ain't got none. It's smooth sailing for satellites. So if you're worried about your satellites, hopefully you're not looking at this if you're worried about your satellites. But anyway, smooth sailing. Electron flux remains quite low, and we can expect this to be even lower in the coming 12 hours. I don't expect the coronal hole high-speed stream to last longer than 12 to 14 hours once the high-speed portion shows up. Probably even less than that. It's going to be a weak and not very long-lasting coronal hole high-speed stream. So anyway, there's the one-year graph of the electron flux from Solon.info. There is the forecast model. It looks like NOAA largely agrees here. We might see a little bit lower levels than that forecast. I'm expecting a little bit lower. But yeah, there's the forecast from NOAA for the relativistic electrons. We'll also show the layer where it's measured in megahertz, the F layer. So there's the F layer of the ionosphere. This is where the GOES 16 and GOES 18 use radiography to measure the electron flux. Keep in mind the GOES 16 and GOES 18 are tens of thousands of miles above this at like 23,000 miles of altitude. The F layer is at about 300 kilometers of altitude, so much lower. Here's the anomaly gram. Anomaly in megahertz from a 30-day median. And I've got the wrong one loaded here. I got 1 hour per second instead of 2. Let's reload that. There you go. There is the anomaly in megahertz from the 30-day median for the ionosphere. And you're going to see a little more red lighting up on this by tomorrow as well, because there will be some minor effects from the coronal hole high-speed stream once the high-speed portion shows up especially. It all depends on the magnetic field orientation and strength, as well as the plasma density and velocity, obviously. Even temperature does play a role. So that's what's going on in the ionosphere. We'll also show total electron content and maximum usable frequency. So that's on the left, that's the free electrons from about 12,500 miles of altitude down to ground level. On the right, the maximum usable radio frequency in megahertz. It's the WHAM, the whole atmosphere model, the global ionosphere nowcast. Last but not least, full disk images. And here's this new sunspot that rose up over the northeastern limb. It doesn't look like a major flare player. Let's take a look at it a little closer here. It is beta gamma class. A little bit too early to say beta gamma delta for sure, but it might be beta gamma delta class. I still like this area in the southwest the best for large solar flares. Anyway, that's where the space weather ends and the meteorology segment begins. So let's start out with the biggest waves in the world. Can you guess where they're located? I'll give you 5 seconds. 4, 3, 2, 1. Now you die! Just kidding. Yeah, those 40-foot waves are located in the West Pacific. So maybe some larger ones down here. Nope, looks like just under 40-foot waves there. That is surface winds and significant wave height. So those are the world's stormiest seas. Let's show the rest of the planet's oceans here just to verify that. Trust, then verify, right? Here is the Atlantic Ocean. We showed you the Pacific already. There's the Atlantic. Here's the Arctic. The Indian Ocean, and the Southern Ocean. Uncharacteristically calm, perhaps. Keep in mind it is summertime down there. So those are the world's stormiest seas, and let's take a look at surface winds and jet streams for the whole planet. There's the eastern world's surface winds, eastern world's jet streams, represented by the 250 hectopascal winds, central world's jet streams, central world's surface winds. Western world's surface winds, and the jet streams of the Americas. Here are clouds and fog of the Americas, depicted by shortwave radiation. Yeah, you can see clouds and fog at nighttime. What are you, some kind of space weather noob? You can't see, I mean, of course, that's Earth weather, but you got to use spacecraft, the 3.9 micrometer infrared radiation satellite, to see that radiation coming off of those clouds and fog. Yeah, water. It emits radiation, folks. Anyway, there's a system here moving across northeastern Nevada and Utah. There's a bit of a low there, just making its way across the Salt Lake and so on. The Great One. The Great Salt Lake. So that's what's up, and here's the coldest place in the world, folks. So take a guess. Where do you think the coldest place in the world is? I'll zoom way in, and it's going to give it away. Oh, man, it's giving it away. Anyway, it's nearly 60 degrees below zero there if you thought it's cold where you are. Siberians are like, we are winner. We are winner. We drink vodka mixed with antifreeze. Here's our weather.gov map, and those are the weather warnings for the U.S., and there are still plenty. Some blizzard warnings in portions of Montana. Also not an indication the sun is shutting down, by the way. Winter. This is the coldest part of every winter, mid-January through mid-February. It's not that spooky, folks. It doesn't mean that the apocalypse is knocking at our door. So, let's show some forecasts. There is some snow in it, and some of it is quite significant. So, that's the next 72 hours, the GFS accumulated positive snow depth change forecast in inches. And if that's got you hiding in a bunker, dude, it's winter. Next, pressure and precipitation, the same model, the GFS 72-hour model. There will be some freezing rain there across places like Oregon and Washington especially, also some in Montana it looks like. Also Idaho, expecting some freezing rain. Don't drive in it. Maybe you have studded tires, but if not, driving in it is fully idiotic. Next, the jet streams. And yeah, there are multiple at times, so don't cross the streams. you could cause a complete protonic inversion or something. Is that a quote from Ghostbusters? I'm not sure. But that's a 72-hour forecast for the 250 millibar winds. The jet stream. Last but not least, temperature anomaly in degrees Celsius. The same model. The cold will let up for a brief period of time in Pennsylvania, where we're located, but then return. So, second wave of cold coming through as the area west of the Rockies, or the western Rockies and beyond, are remaining anomalously warm. Must be all that hot air coming out of Colorado. What do you think? Let us know in the comments. Next, we'll show lightning. And by the way, thanks for tuning into the Smash News Network, least busted name in news. That's lightning for the past, 10 hours, something like that. And here's a real-time lightning map from lightningmaps.org. Highly recommend it. Next time you hear thunder, convince the natives that you're Zeus or something. Pretend you're a horror movie villain by saying something ominous just before thunder rolls in. What a pile of Bologna. Bologna! Anyway, that's a real-time lightning map. And by the way, make sure you subscribe to Eugene the Philosopher, or we will find you and we will shame you. That's the guy who authors our Ask a Particle Physicist segments. And by the way, special announcement about that. There's a thing that's going to happen on Saturday. A thing will occur on our channel on Saturday. In the meantime, go subscribe to Eugene the Philosopher, you sociopath. And if you want to submit questions for the Ask a Particle Physicist segment, the best place to do so is at smashomash.com/forum. We built a massive web ring for people like you noticing the pathetic and putrid censorship on the internet. So we built a massive web ring, and, it's up to you to utilize it, though. You can, to quote Jeremy from Pure Ownage, you can, lead a noob to water, but you can't, make a noob, drink. We'll close out the video with U.S. Doppler radar for the full 50-state view. Then we'll focus on the lower 48 view. And if that's too much data for you, then screw you. There is clouds and fog over the lower 48. And there is water vapor. Oh my God, look out. There's moist air and dry air over the country at the same time, folks, which leads to massive pressure and temperature gradients, which leads to these things called weather. Oh my God, here's your recap U.S. Doppler radar. It's enough to have you hiding in a bunker, folks. Get in your bunker now while there's still time. Fire up that wood gasifier and have a bunch of batteries and lighters and things, because reasons. There is clouds and fog once again, and there is water vapor. When your Doppler radar makes no sense, like it's about to over Texas, try the water vapor map. It'll make things clear, especially if you understand basic and much more complex atmospheric physics. If not, you probably can't forecast the weather. So thanks for tuning in, and congratulations once again on realizing the channel exists. I've been your host, Dan, a.k.a. Smash O Mash, signing off, and may that solar wind be at your back. And I'm going back to the bunker. Whoa!